This video will be on 6.3b solving rational equations. And so if you remember when you first learned to solve equations that included fractions, like if we did, 2/5 x plus 1/2 equals 3/5. This could be a challenging problem because you have to subtract a half on both sides, and then to take 3/5 minus a half, you have to have a common denominator, and then you have to divide by a fraction. So what we were taught to make this problem easier is if you want to clear out the fractions, what you can do is multiply everything by the lowest common denominator. So between fifths and halves, the lowest common denominator would be 10. So if you take and you multiply everything in this equation by 10, as long as you do it to everything, it won't change the value of the equation. And then you can reduce. So 10 over 5 reduces to 2 over 1, and 2 times 2 is 4x. And then 10 over 1 times 1/2 reduces to 5 over 1 plus 5 equals, and here we get 1 over 2 equals 6. And then now you're able to just subtract 5 and divide by 4. So you would just get x equals 1/4. And so it's much easier to solve the equation once you have those whole numbers. And so that's kind of the idea behind today's lesson with solving rational equations. It's going to involve some fractions. And if we can go back to the basics of linear equations with fractions, and we can solve these rational equations as well. So what we're going to want to do to clear out these fractions first is to multiply everything by the lowest common denominator. But before we do that, we want to make sure that we state any restrictions for x. So our first step is to state any restrictions. And so since these are absolute value, not absolute value, rational functions, sometimes they have restrictions. And the restriction for this one is that x cannot be equal to 0. And that's because in the original equation you have 3 divided by x and 12 divided by x, and you cannot divide by 0. It is undefined. So our one restriction is x cannot equal 0. So in our domain, it could be all real numbers, but not 0. And then for 2, we want to find the lowest common denominator, so step 2. So you have an x and a 2, so your lowest common denominator for this needs to be 2x. So then step 3 will be multiply everything by the lowest common denominator. So I'm going to take the first fraction times 2x, second fraction times 2x, and the third fraction times 2x, or that's 2x over 1. So in the first part, the x's will simplify to 1. 2 times 3 is 6. 6 over 1 is just 6. Minus 1/2 times 2 over x. The 2's simplify. And then it's just 1 times x over 1. So x. And then equals. Then the x's simplify again. And 12 times 2 is 24. And now you just have a simple linear equation. So you can solve by 2 steps. Start by subtracting 6 on both sides. 24 minus 6 is 18. And I did have a negative x, which means essentially a negative 1x. So to get rid of that negative x, divide both sides by negative 1, and x equals negative 18. And negative 18 is within our domain, so that is possible here. It just can't be equal to 0. All right, for this one, we'll state our restrictions. We can't have the denominator equal 0. So here we have an x plus 1 in our denominator, and we cannot have that equal 0. So if you think, what would make that equal 0? And if you solved it for x, you would say, well, x can't be negative 1. Sorry, my husband was calling me here, so I was just going to text him. Okay, so x cannot equal negative 1. Then let's find our lowest common denominator. So we have 4. Well, that's the same thing as just 4 over 1. So we have x plus 1, 1, and x plus 1. So our lowest common denominator is x plus 1. Step 3 was multiply all by x plus 1, then our lowest common denominator. So if we take this first fraction and multiply it by x plus 1, the 4 times x plus 1, and this times x plus 1. So we get x plus 1 divided by x plus 1 is 1, so 5x equals 4 times x plus 1 is 4x plus 4, if you distribute that 4 to both, and then minus 5 because the x plus 1s simplify. Combining like terms, I'm going to get 5x equals, we have a 4x minus 1. And then I'm going to finish solving this by subtracting 4x on both sides because I want my x's on one side and my constants on the other. 5x minus 4x is x. I get x equals negative 1. So x equals negative 1 is my answer, but x equals negative 1 was also my restriction. And so I can't have x equals negative 1. So this is called an extraneous solution. Essentially, it looks like it's an answer, but when we plug it back in, it makes the equation itself undefined. And so there's no other options here, so there'd just be no solution. Sometimes you might have 2 answers and one of them is extraneous. So one is okay, but one is not. If you have only one answer and it's an extraneous solution, then there are no solutions that work for this equation. So no values of x would make this equation true. Okay, so here's one where we might have 2 solutions. So I always like to state my restrictions right away. So it might help to factor this x squared minus 4. Remember, that's difference of perfect squares, so x plus 2 and x minus 2. And so we can't, x plus 2 cannot equal 0, and x minus 2 cannot equal 0. So we have 2 options here. We cannot have negative 2, and x cannot be positive 2 either. Because either one of those would make the function undefined. The lowest common denominator for this one is going to be that x squared minus 4. Or x plus 2 and x minus 2. Because this denominator has an x minus 2 and this one does too, but it also has an x plus 2. So you need both. So multiply everything by x plus 2 and x minus 2. And then this one times, and then 1 times. Okay, then simplify by canceling those 2. So I'm going to get x plus 2 and 3x minus 2 equals, here in the 6's, everything will simplify there. So we just get 6 plus, and then 1 times x plus 2 and x minus 2. So then multiply this out. You'll have to either FOIL this or use your box method. If you do the box method, it's x plus 2 times 3x minus 2. So 3x squared, 6x, negative 2x, and negative 4. It leaves you with 3x squared plus 4x minus 4 equals, on this side, remember this is really just x squared minus 4, and we have the plus 6, so it'll be x squared, and 6 minus 4 is 2. Now we have a quadratic equation because we have a 3x squared. So to solve a quadratic equation, whenever you have an x squared, it has to be equal to 0. So I'll have to subtract x squared on both sides, and I'll have to subtract 2 on both sides to move everything to one side. So 3x squared minus x squared is 2x squared. The x squareds don't cancel. It's 3x squared minus 1x squared. And then I have a plus 4x, and then negative 2 minus 2 is negative 6 equals 0. Now, it's possible that I could factor this and solve it, or you can always use the quadratic formula. I do notice that each one of these is divisible by 2, so I can divide everything by 2 first and get an easier equation to work with. And then I'm always going to check to make sure if it factors before I do quadratic formula. So multiplies to negative 3, adds up to 2. Yeah, you can do that. Be negative 1 and positive 3. It's just x squared, so you know it'll be x minus 1 and x plus 3. Remember, you can do that when it's just 1x squared because x times x is x squared. And then it's just your diagonals that give you your factors. And then once you have it solved by factoring, you set each factor equal to 0, or to finish solving by factoring. So you get x equals 1 and x equals negative 3. And then our restrictions were 2 and negative 2, so both of those solutions work. Whoops. So I have two answers, x equals 1 and x equals 3. So when you have a single rational expression or one fraction equal to another fraction, you can solve it using cross multiplication, which is what you learned back with proportions. So like, to give you an easy example, you know that 1/2 is equal to 5/10, but you could say that 1/2 is x over 10. You know it's supposed to be 5, but then you can cross multiply, so you get 1 times 10 is 10, and 2 times x is 2x. Then you can finish solving, and x equals 5. Divide by 2 on both sides. So cross products in a proportion are equal. So if you have two fractions just set equal to each other like this, instead of multiplying by the lowest common denominator, which you still could, you can cross multiply. It has to be one fraction set equal to another fraction. You can't have like another fraction being added over here, or you can't use the cross multiplication method. So here, if you cross multiply, you get 3 times x plus 4 has to equal the product of 1 times x squared plus 4. So x squared plus 4x, I mean. Then you have to distribute on the left. And then it leaves me with a quadratic. So you do have to set it equal to 0. So I'm going to subtract 3x. I'm also going to subtract 12. So it'll be x squared plus 1x minus 12. Multiplies to negative 12, but adds up to positive 1. See, negative 3 and 4. So x plus 4 and x minus 3, which means your answers for x will be negative 4 and positive 3. Now, I forgot to state my restrictions, so I'm going to go back up here and check that. And I have an x plus 4 can't equal 0, so you can't have negative 4. I guess I didn't have to box that. But so x negative 4 is a restriction. And this one, if I take out an x, I get x plus 4. So I also have an x plus 4 again, so can't have negative 4 for this one. And then for the single x, it means that x cannot be equal to 0 either. Because if I plugged in an x in that first fraction, if I plugged in 0, I'd get 3 divided by 0, which is undefined. So I can't have 0 and I can't have negative 4. So this one is not a solution, which means I only have one solution here, which is x equals 3. So find the least common denominator. It's a helpful hint. Make sure you check for extraneous solutions. Make sure that when you plug them back in, you're not dividing by 0. It's a restriction. Cross multiply when each side of the equation is a single fraction. It'll make things easier. Thanks for watching.